Vector projections. So when we break our vector down into our components, what we're doing is we're projecting that vector onto the x-axis and to the y-axis. So something like this, there's our vector OP. I can drop down a horizontal, and there would be our horizontal component. Bit of trig, easy enough to work out. 2 times the cosine of 30, so it would be root 3. So we know the horizontal component is root 3i. Vertical, this time draw a horizontal in. Again, bit of trig. That one turns out to be 1. And so the vertical component would be j. So our vector we know is root 3i plus j. So basically you're just dropping a perpendicular and a horizontal. But there's no reason why what we project onto have to be horizontal and vertical. You can project to any ones you want. So let's say, for instance, here's the vector u, and I want to project it onto the vector v. Now I still have to project down to 90 degrees. So from the endpoints of my vector, I draw a perpendicular to my line, or my other vector. So that red one that's sitting on the blue line now, that would be the projection of the vector u on vector v. So we need to calculate its length. Well, we can still use that idea of trig to calculate the length. From the end of my vector there, you'll see I've drawn in a line parallel to the other vector, which would create a right angled triangle, because remember we dropped it perpendicular. And so again, we could use trig, and that side would be whatever the magnitude of u is, times the cosine of theta. Then, if I multiply that by the unit vector in the direction of v, we'll get our red vector on this, that's sitting on the blue line. So the projection of u onto v, to work it out, would simply be the magnitude of the u vector times cosine theta times the unit vector in the v direction. Now, we can take this a bit further, because we know that u dot v, we said it was the magnitude of u times the magnitude of v times the cosine of theta. So therefore, the magnitude of u times the cosine of theta, rearranging that, I get u dot v on the magnitude of v. So therefore, our projection, we can now write it this way. We don't actually need to know that angle. We can say, well, it's u dot v over the magnitude of v times the unit vector in the v direction. Now, the unit vector in the v direction, if you recall that one, was the vector v divided by the magnitude of v. So now I get u dot v on the magnitude of v squared times the vector v. Now notice it's times. So it's not a dot. We can't do a dot product. We can't cancel the v with the magnitude of v. Doesn't work that way. So we leave it as u dot v on the magnitude of v squared times the vector v. So there's a little formula there, if you like. So dot products and division, they're not inverse operations of each other. Okay? So that's why we can't cancel those. A couple of notes about this. If you wanted to find the projection of a scalar times the vector u, then you could actually, if you like, think of it as factorising the scalar out. You can find the projection of u on v and then just multiply it by the scalar. And addition works for this. So if you had to find the projection of 2 vectors, the sum of 2 vectors on another vector, then you could find the individual projections on both and add them together. Let's do some examples then. We're going to project the vector A onto the vector B. All we're interested in at this stage is the length of it. So the length of it would just be the A dot B over the magnitude of B. Okay, so we haven't multiplied it by the unit vector. Just that. So A dot B, 5 times 3 plus negative 1 times 4. Magnitude of B, square root of 3 squared plus 4 squared. And it totals up to be 11 on 5. Now that length sometimes is known as the scalar projection. So the length of the projection. All right, let's do one where we actually find the projection of these two. So 2 minus 5j onto negative 2i plus 3j. So it'd be the u dot v over the magnitude squared, so I don't have the square root sign on the bottom, but times the vector we're projecting it onto. And all of that tied up to be minus 19 on 13 times minus 2i plus 3j, which so that wonderful expression, 38 on 13i minus 57 on 13j. Excellent. So exercise. 2 jolly good fellows. Very good. There you go.